Hello guys, welcome again into our second class in the calculation of the variance and the continuation of the calculation of the standard deviation. So today we're going to focus on a very unique parameter called standard deviation and its application in financial statistics. As we had discussed earlier about the application of the variance in the financial statistics. So today we're gonna calculate a standard deviation and we're gonna explain what are some of the application of the standard deviation in the financial statistics. So what is standard deviation? Standard deviation is simply a measure of how numbers are being spread out from the actual mean. Therefore, for you to calculate standard deviation in statistics, you must understand how to calculate the actual mean or the arithmetic mean. You also have to understand how to calculate the variance, and then finally we're going to calculate a standard deviation. So standard deviation is applied in financial statistics to do what we call the portfolio management. Different companies or different individuals invest in different assets, and therefore in portfolio management, during the investment in a particular investment period, then standard deviation is used to do what we call the risk analysis and the returns balancing. And then it can also be used in risk assessment, especially by checking different degrees or levels of risk, and therefore the higher the standard deviation, the higher the risk, and the lower the standard deviation, the lower the risk. Therefore, without further ado, let's proceed. We will formulate, or we will provide a simple data where we can derive our calculation from. So we have company X, investing in stocks or shares. So standard deviation. Standard deviation. So we have said standard deviation, it is applied in portfolio management, risk analysis, and also is used for risk assessment. Risk assessment. So we will have our data here. And our data will entail, in our first row we will have investing period, and then we will have return in percentage. We'll have return in percentage. So this row here, it will provide what we call the data point. We'll have our data point, and then investing period will be in terms of days. So we'll have day 1, have day 2, we'll have day 3, and finally we have day 4. So we have day 1, day 2, day 3, and day 4. Therefore, in day 1, the company got a return of 6%. 6%, and day 2, the company got a return of 8%, and day 3, the company got a return of 10%, and day 4, the company got a return of 12%. 12%. Are you together up to there? So now what we have here is what we call the data point. We call the data point, and this day 1 to day 4, it will be our n, and therefore this one is our sample data. Therefore, we have a unique characteristics when we are dealing with sample data or population data in statistics. Why? Because when we are dealing with sample data, we're going to consider what we call degree of freedom. Degree of freedom to adjust to biases or errors that may happen during data collection. Therefore, our n will be n minus 1, because we have to adjust to biasness or any other factor that may affect the data distribution or during our sample collection. And when you are dealing with population data, you're going to use capital N, where the capital N is the total count. This represents total count, and it cannot deviate away from what we call the discrete data, where the numbers are expressed in terms of whole numbers, because when you have a population of 10 cows, there are 10 cows. You don't have 9 cows and a half, right? That's simply what it means. So now let us proceed with the sample data analysis. How do you calculate the mean? So we said that our mean will be the summation of fx divided by n, where n is just the frequency or the total frequency, or the number of the observation, simply. So we will have the summation of fx, where f, we say it's the frequency of each class interval multiplied by the average of each class interval. So it's simply the total product of each class interval and its corresponding frequency. So we have our 6 here plus our 8 data point plus 10 plus 12. So our answer here will be 18 plus 12 plus 6 is 36. And then we have our n, which is equivalent to 4 days. So this data was collecting at an interval of 4 days. So we will divide everything by n, which is 4. So our mean value will be equivalent to 36 divided by 4. 36 divided by 4, I think, is 9. 36 divided by 4 is equivalent to 9. So our mean value here is 9. Then we will proceed in calculation of what we call deviations. We proceed now to step 2, where we will calculate what we call deviations. So, deviation are calculated by using the variance formula, which is the summation or sigma of data point minus our mean, then you square. So from each data point. So our deviations here will be 6 minus 9 squared plus 8 minus 9 squared plus 10 minus 9 squared plus 12 minus 9 squared. So our deviation will be minus 3 squared plus minus 1 squared plus positive 1 squared plus positive 3 squared. It gives out a total of 9 plus 1 plus 1 plus 9, total of 20. Therefore, at this point you can be able to calculate the variance. So our variance will be given by the summation of x minus mean squared divided by n minus 1. Because remember, we are dealing with the sample data. So answer will be 20 divided by 4, which is equivalent to our n minus 1. So our answer will be 20 divided by 3, which is equivalent to 20 divided by 3, which is equivalent to 6.667. After calculation of our variance now, we will proceed with the calculation of standard deviation, where standard deviation is given by the square root of summation of x minus the mean square divided by n minus 1. We have already calculated this here. Therefore, we're gonna do or simply the square root of variance. The square root of variance. So our answer will be the square root of 6.667, which is equivalent to approximately 2.58. This is our standard deviation. This is our standard deviation. Now we come to a very critical point of interpreting the data. What does this mean? This simply means that if the distribution of the data was normal, under what we call normal distribution, we will use what we call the empirical rule. The empirical rule simply states that at 68% chance the data falls one standard deviation of the of the mean. Therefore, empirical rule, it is designated with a very unique scale of 1 to 3. Don't worry guys, I'm gonna demonstrate. So, the empirical rule of the normal distribution, it has a scale of 1, 2 standard deviation and 3 standard deviation, whereby you'll find on our scenario we have 2.58%, which is our standard deviation. So if we were to use the empirical rule to interpret our data, we will see the amount of return in terms of percentage that we will get at 1 standard deviation, which is equivalent to 68%. So this is 95%, so this is 99.7%. So at standard deviation 1, using the empirical rule, you'll find that from a scale of 9, using our mean 9 plus or minus 2.58 standard deviation, we will find that the return will be within a range of 6.42 to 11.558. It's the same case when you do with the 95% at a scale of 2 standard deviation. You will find that the return will fall under, you just simply use the 2 times the standard deviation. We use 2 times standard deviation will be 2 times 2.58, here we get 5.16. It is equivalent to 9 plus or minus 5.16. So this simply means the return at this chance of 95% will fall under what we call a range of 3.84 to 16.14. To 16.14 to 16.1 to 16.14 to 14.1, to 14.16. That is the return that you get under the second scale of empirical rule, that is under 95%. So guys, I would like you to calculate how much return will be earned when we use a scale of 3 standard deviation at 99.7% of the empirical rule. Thank you for watching. Let's meet in the next lesson.